Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. Today, we're diving into a fascinating area, human-like episodic memory for infinite context LLMs. So, what are your initial thoughts on this?
My initial thought is that this is a huge leap forward. The idea that we can start imbuing these large language models with something akin to episodic memory, that's bordering on science fiction becoming reality. It's no longer just about regurgitating facts. It's about the model potentially remembering and contextualizing information in a way that mirrors human experience. I think that why with uses for applications, mind-boggling.
I'm a little more skeptical. I think the phrase human-like episodic memory is doing a lot of heavy lifting here. Are we really talking about genuine memory, or just a sophisticated form of pattern matching and retrieval? I worry that we're anthropomorphizing these models and giving them capabilities they don't actually possess. It's not real memory if it doesn't have the feeling of remembering, you know?
I agree with you to an extent. I think calling it human-like is a bit of a stretch. But I'm interested in the infinite context aspect. My perspective on AGI is that it critically needs is spatiotemporal understanding, right? Knowing where and when something happened is fundamental. So, if these models can truly handle infinite context, maybe they're starting to implicitly learn some rudimentary form of spatiotemporal reasoning, which would be a significant advancement.
That's a really interesting point, Donald. And Sarah, I understand your skepticism. I share some of it. But even if it's just sophisticated pattern matching, the implications are huge. Think about applications in personalized medicine, for instance. If an LLM could remember every interaction a patient has had with the healthcare system, I've reported every interaction a patient has had with the healthcare system, I've reported every test result and contextualized that information, that could lead to much more accurate diagnoses and treatment plans.
Exactly. And beyond medicine, imagine customer service. A truly infinite context LLM could remember every previous conversation you've had with a company and provide seamless personalized support. Or in education, a virtual tutor that adapts to your individual learning style and remembers your progress over time. The key here, I think, is the infinite context. Current models have limited context windows, meaning they quickly forget what you told them just a few minutes ago. Removing that limitation is a game changer.
But isn't there a danger of these models becoming echo chambers? If they're only trained on past data, won't they just reinforce existing biases and stereotypes? True episodic memory involves learning new things, adapting to novel situations. Can these models actually do that, or are they just regurgitating patterns they've already seen?
That's where the spatiotemporal aspect comes back in. To truly learn from new situations, the model needs to be able to understand how those situations relate to its existing knowledge in both space and time. It can't just be a flat, linear sequence of events. It needs some kind of internal model of the world, a virtual sandbox as I think of it, where it can experiment and explore different possibilities. Current models, they operate in a very static coordinate frame, if you will.
So, Sarah, you're hinting at the need for something beyond just deep learning, perhaps neuro-symbolic approaches. Is that where you see the field moving?
Absolutely. I think we need to integrate symbolic reasoning into these models. They need to be able to manipulate abstract concepts, not just statistical probabilities. I want an AI that knows what justice means, not just how to predict the next word in a sentence about justice. The current deep learning approaches, while impressive, feel like we're building a really elaborate house of cards. One small shift in the data, and the whole thing could collapse.
But isn't the sheer scale of these models mitigating that risk? The more data they're trained on, the more robust and generalizable they become. Look at the recent advances in image recognition. Models trained on billions of images can now identify objects in almost any context. Isn't it possible that the same will happen with language? That with enough data and compute, these models will eventually develop a form of emergent understanding?
I think that emergent understanding will always be limited without some kind of fundamental shift in the core algorithm. It's like trying to build a car that can fly by just adding more and more powerful engines. At some point, you need to change the underlying design, maybe add wings. For AGI, we need algorithms with the ability to learn and translate across different coordinate frames. We're just applying brute force right now.
Okay, so Otto, you're advocating for more data and scaling, while Sarah and Donald are pushing for more fundamental algorithmic changes. What specifically, Sarah, are you thinking of in terms of neuro-symbolic approaches? Can you give us an example?
Sure. Imagine a system that combines neural networks with knowledge graphs. The neural network could learn to extract entities and relationships from text, while the knowledge graph could store that information in a structured symbolic format. The system could then use logical reasoning to answer questions, make inferences, and even generate new knowledge. For example, you could ask the system, "What are the potential side effects of this drug?" And it could use the knowledge graph to trace the connections between the drug and various biological processes, identifying potential risks that a purely statistical model might miss.
That sounds interesting, but wouldn't it require a huge amount of manual effort to build and maintain the knowledge graph? And wouldn't the system be limited by the knowledge that's already in the graph? It seems like it would be much less adaptable to novel situations than a purely data-driven approach.
I think the key is to have the system learn the knowledge graph itself, to self-organize its internal representation of the world. And that requires the ability to understand the spatial and temporal relationships between different concepts. Think of how a child learns about the world. They don't just memorize facts. They explore their environment, interact with objects, and gradually build a mental map of how everything is connected. We need to create AI systems that can do something similar. My idea of having them have a coordinate system that they are able to translate is fundamental here.
So building on Donald's point, how do we translate that idea of a child exploring their environment into a concrete algorithm? What would that look like?
Well, one approach could be to use something called geometric deep learning. This involves developing neural networks that can operate on non-Euclidean spaces like graphs and manifolds. This would allow the model to represent relationships between concepts in a more flexible and nuanced way. It also allows for the development of internal simulations, like a child exploring a world.
Geometric deep learning? That's interesting. But isn't it still just a form of deep learning? Are we really solving the fundamental problem of understanding, or just finding more sophisticated ways to fit curves to data?
I think it's a step in the right direction, but it still needs to be combined with symbolic reasoning. The geometric deep learning could help the system learn the structure of the knowledge graph, but it needs a symbolic layer to actually manipulate and reason about that knowledge. It's about building a hybrid system that combines the strengths of both approaches.
Okay, let's bring this back to the original paper on human-like episodic memory. Do you think these infinite context LLMs are implicitly learning some of this spatiotemporal reasoning, even if they're not explicitly designed to do so?
I think it's possible. The more data they're trained on, the more likely they are to pick up on subtle patterns and relationships in the data, including temporal sequences and spatial correlations. It might not be a conscious understanding, but it could be a form of implicit knowledge that they can use to improve their performance on various tasks.
I'm still skeptical. I think they're just learning to predict the next token in a sequence based on the previous tokens. They're not actually understanding the underlying meaning or context. It's like a parrot that can mimic human speech, but doesn't actually understand what it's saying.
I think it depends on how you define understanding. If understanding means having a conscious awareness of what you're doing, then no, these models probably don't understand anything. But if understanding means being able to effectively manipulate information and solve problems, then I think they might be starting to show some signs of understanding. The base model's doing a better job at creativity than aligned models also hints at underlying issues.
That's a really important distinction, Donald. So even if these models aren't conscious, they might still be useful tools for solving complex problems. And maybe that's all that matters, at least for now.
Exactly. And I think we're still in the early days of this technology. We're just starting to scratch the surface of what's possible. I think in the next few years, we're going to see even more impressive advances in the field as we continue to scale up these models and develop new algorithms.
I hope you're right, Otto. But I also think we need to be careful not to get too caught up in the hype. We need to make sure that we're developing these technologies responsibly and that we're thinking about the potential ethical implications. I think neuro-symbolic approaches will help mitigate some of the risks.
I agree. And I think we need to focus on developing models that are not just powerful, but also transparent and explainable. We need to be able to understand how these models are making decisions so that we can trust them and ensure that they're not perpetuating biases or engaging in harmful behavior. We need to solve the coordinate system translation issue.
Okay, so looking ahead, what are some specific research directions that you think are most promising based on this discussion? Let's start with you, Otto.
I think the most promising direction is simply to continue scaling up these models and training them on even more data. I think we're going to see diminishing returns at some point, but I don't think we're there yet. I also think we need to develop better methods for evaluating these models, beyond just measuring their performance on benchmark tasks. We need to find ways to assess their understanding, their reasoning abilities, and their creativity.
I think we need to focus on developing neuro-symbolic architectures that combine the strengths of neural networks and symbolic reasoning. I want to see more research on how to integrate knowledge graphs, logical inference, and other symbolic techniques into these models. I also think we need to explore new learning algorithms that are less reliant on massive amounts of data and more capable of learning from limited examples.
I think the key is developing algorithms that can translate between different coordinate systems and understand spatiotemporal relationships. I'd like to see more research on geometric deep learning, as well as other approaches that can represent and manipulate spatial and temporal information. Also, I want to investigate internal simulations of the world.
From my perspective, I think a key area needing exploration is the way humans link sensory experiences, emotions, and associated memories in a richly contextualized manner. Could we build computational models that capture and replicate this rich interweaving of factors, rather than simply focusing on input-output correlations? This might pave the way for LLMs that exhibit a more nuanced and human-like understanding of the world. Also, I believe we need to explore the neural correlates of randomness and creativity to create novel AI paradigms that leverage the emergent properties of complex systems.
That's a really interesting point about the link between emotions and memory. I wonder if we could incorporate some kind of emotional module into these models to see if it improves their performance. It is another area that needs a lot more data.
I'm still skeptical about the idea of emotions in AI, but I do think that incorporating more contextual information into these models is crucial. We need to find ways to give them a better understanding of the world around them so that they can make more informed decisions.
I agree. And I think that contextual information needs to be represented in a way that's both flexible and structured. It can't just be a flat list of facts. It needs to be organized in a way that reflects the underlying relationships between different concepts. Translation between coordinate representations here is really helpful.
Well, this has been a fascinating discussion. It's clear that we're still a long way from achieving true human-like intelligence, but the progress that's being made is truly remarkable. Thanks to you both for sharing your insights, and thank you to our listeners for joining us on Cognitive Spirals. Until next time.